The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to this month's edition of our AMS webinar. Today's webinar is going to be a pretty interesting one, where we're actually going to be showing how to program a real-world guitar body using both 2.5 axis and 3 axis methods in RhinoCAM. I mean, the same things would apply for Visual CAD/CAM as well. Before we get started, as usual, use your chat window for questions. We want to keep it as interactive as possible, and we welcome your questions always. And we typically reserve some time at the end, if time permits, for some additional questions and answers. And if we can't get to it during the webinar, we'll definitely send you an email with answers to any of your questions. My name is Joe Anand, and I'm sorry, before I go do the introductions, I also want to let you know that a recording of this webinar will also be made available in a couple of days to all those people who have registered. We'll send it out as an email link. My name, as I mentioned before, is Joe Anand, and I'm the product manager here. I'll be joined today by Don LaCourse, who's actually going to be doing the show and tell. So today's agenda, the topic is, as I mentioned before, is machining a real-world guitar body. So we're going to show two different ideas or two different concepts here. One is using our standard configuration. We're going to be showing how do we program the body using our standard configuration. A lot of our customers have the standard configuration, so we wanted to make sure that we focus on those methods. And then also, Don is going to be showing a professional, some of the methods that are available in our professional configuration and some of the nice finishing methods that might make your job easier. And he's going to be showing those as well. As far as the actual topics that are going to be covered, he's going to start with part setup and fixturing, creation of stock models, and then also talk a little bit about two-sided machining. We've done webinars on that before, called a flip machining. He's going to be talking about that a little bit here because this body actually has features on both sides of the part. Then some 2.5 axis methods to do the facing and multi-depth pocketing for the pickups. It's actually an electric guitar body, so it's got holes for pickups and things like that. So which he's going to be using 2.5 axis methods for machining those pockets out. And then the finishing methods would be the 3 axis parallel finishing because it's got a lot of sculpted surfaces as well. All right, so Don, without any further delay, do you want to take over?
Yes. Hello, everyone. Thanks for joining us today. This webinar is going to be really interesting. We're going to be programming the guitar body that you see on the screen right here. What we have labeled here are just the types of features that we're part features that we're going to be programming. So if we start on the left, which is the top, and on the right is the bottom side. So as Joe mentioned, we've got various pockets for the pickup areas, and as well as facing to just face off the stock. We've got some contoured surfaces here and more contoured fillets going all the way around the part. So I'm going to be showing you actually some new 2024 features for fillet machining, which is really cool. So basically, we're starting with a 3D solid model, or what we call a poly surface model. So this is a NURBS model, NURBS surfaces. And over here on the right, we have facing and then contour fillets around the perimeter. So let's just hop right in. So here is the guitar body. Okay, so we got the top and the bottom, and we've got a number of layers over here. I'll tell you what those are in just a moment. We have already our tools set up ahead of time. Okay, so we've got 3/8" flat mills, 3/8" ball mill. We have a face mill cutter. We have a corner radius mill, and then we have 2 more flat end mills, a 1/4" and a 1/8" flat end mill. So the finishing can be done with the 3/8 ball, and then the rest with the flat mills. And let's see what else we got going. Let's talk a little bit, as we mention every time before you start a CAM project, you need to take a look at your part, get familiar with every feature on your part, and get it set up in your mind how you're going to approach it, and obviously also how you're going to fixture the part during machining. A two-sided machining or a flip machining part, the fixturing obviously is paramount. How you need to work that out. In this example, we're assuming that we have a vacuum table that's going to hold down the part during machining. And we're also going to be fixturing the part for flip machining, and I'll show you how that's done. So the easiest way, there's multiple different ways of flip machining, and people have different ways of doing it. I'm going to show you the easiest way and one that guarantees no mistakes, because when you go flipping geometry around and you're concerned about getting it aligned top to bottom, things can go wrong, and then if they go wrong, then it makes it real complicated to try to fix what's going on. So this approach is going to be almost error-free. Okay, so the way to do that is to model your stock box. Okay, so you're going to position your stock box right over top of your model, how it's going to be positioned on the table. Okay, so we've got a box and we got our guitar body placed inside it, aligned and everything. This method right here, when you go to moving parts around, flipping them around, this is going to ensure that your guitar body stays aligned with your stock model. Okay, and we're also going to be using the stock model in order to create, obviously, the stock. Okay, and you'll see that I modeled some holes in the corners. The standard configuration, we're just going to be using the box as the stock. But when we talk about actually flipping the part over, if you look at it, okay, we're looking along the y-axis on the long side and the x-axis on the short side. We're going to be actually flipping the part over like this, okay? And for this example, we're going to be using 2 of the register pins for flipping it over. You always want to just use 2 and not over constrain your model. 2 fixture locations is all you need to align this part. Okay, so let's go ahead and get started how we're going to program this in the standard configuration. So what we're going to do, as we always do, we're going to start on the program tab. We're going to start at the left and work our way to the right to program this part. We'll start with the machine. Obviously, we're doing 2 and 3 axis operations, so it's going to be set to 3 axis, and there's really nothing else we need to do there. And you'll see that the items are showing up in under the machining job. So for our post, we're not going to be really talking about posting in this video. It's just set to the default post, so we'll leave it at that. And the setup, we're going to be looking at in the standard configuration, we're not going to be orienting the part. Well, we will be orienting the part when we do the flip side, but we won't be using the setup or the rotate table setup options. Okay, so go to the stock. Again, you got to have your stock layer turned on, and we're going to go to the stock. For the standard configuration, we're just going to do a box stock, and we're going to select the copy model bounding box option, which snaps the stock to the stock box, and we'll pick OK there. Now, once the stock is defined, you don't need the stock model layer. We're going to turn that off. And here is our stock model, okay, with the guitar body positioned in the center of the stock. So for this particular example, the stock is already aligned at the world origin in Rhino. So the bottom left corner of the stock model is located at the WCS origin in Rhino, okay? And we're going to be putting a work 0 or the machine 0 at the top of the stock in this corner as well. And when we go to flip the part, you'll see how easy it is to get this aligned correctly. Okay, so we've got one setup, as I mentioned, and it is aligned with the world origin. These are just toggles here. This is the WCS origin. I'm going to leave that turned off, and this is the machine coordinate system origin. So this is the setup one orientation, X, Y, and Z. So we're machining the top, okay? So the first thing we're going to do is we're going to add a machine 0 or work 0, and we're going to set it to the stock box. Now, you need to, in the method we're using to flip this, you want to use the stock box, because when we flip it over, you won't have to change your work 0. It'll automatically snap to the correct location. So we're going to use set to stock box, and we're going to use highest Z, southwest corner. So this is the machine 0 we're going to use. We'll pick generate. Okay, so now you'll see that the machine coordinate system moved from here to the top of the stock. So that's going to be our machine 0. Now we can go ahead and turn the stock off. So we're going to start with some 2-axis facing and pocketing. We're going to face the top of the body, even though the stock is the correct height. We're just going to run a face mill across it just to make sure it cuts off any ambiguities in the surface finish of the stock itself. So we're going to go to 2-axis. And again, as we go through this, if you got any questions, just type them in the questions bar, and we'll stop and get them answered. So we're going to go to the 2.5-axis menu. And again, as Joe mentioned, we're programming this in the standard configuration. Even though you see the professional, all these other options, we're only going to be using the options that are available in the standard configuration. So pretty much all of the 2-axis options are in the standard except for a few. We're going to go ahead and do the facing. And we have a number of curves already defined on this part. You see there's all our curves that we have created. So for the 2-axis, we're going to be using curves to define the control geometry. So for the facing, we're going to go ahead and pick the select curve edge regions, and we're going to use this curve right here for the perimeter. So this is the perimeter of the face that we're going to use, and that's the only curve that we need. So there's our control geometry region. And for the tool, we're going to use our 2-inch diameter face mill. We're not really going to talk about feeds and speeds or clearance. We're just going to leave all these set to the default parameters. For roughing, on this facing, we're not really concerned with tolerance or stock, because the center of the tool is going to go to the boundary. It's going to base it off correctly. All we really need to pay attention to really is our cut pattern. We're going to do an offset pattern, so it's going to be going around the perimeter as it cuts. This is really the most important level in facing. Where are you going to face at? So we're going to be facing at the bottom of our geometry. So the geometry we selected is going to be at the bottom of the cut. Because it's at the bottom, we don't need any depth parameters. They're all going to be set to 0. So it's just going to machine at the bottom or at the control geometry we selected, just one level. okay? And for the facing entry and exit, we can use some lines and arcs since we're going to be coming in. Actually, we're not facing off the entire block. So let's go ahead and use a ramp motion because we're going to be just machining a subsection inside the stock area. So we'll do a ramp entry and we'll go ahead and do just a retract straight up at the end of the cut. And doing for the along path, you can set the angle and the height. We're not going to mess with those, just use the defaults. And for the advanced cut parameters, we have some arcs in here. We don't really need to do arc fitting. We'll just leave it set to the default parameters and generate it. Okay, so here's our facing toolpath. And let's go ahead and start our simulation. Just check our simulation preferences. So we're going to use the polygonal model. We're going to use simulation accuracy set to fine. For machining, we're going to have the part sampling resolution set to fine. Our default tolerance is 1/1000th. And let's look at what else we got. Let's change some colors for the stock model so we can see it a little bit better. Okay, and that's pretty much all we're going to use there. Let's just do one cursory look. Stock, cutting tools, and speeds and speeds. We're not going to be messing with that. We don't need anything there. A toolpath, we're going to set the display to 2, which makes them stand out a little bit better so you can see them. Simulation, we went over that. User interface, we don't need to change anything on the rest of it. We'll just pick OK. So now we'll just go ahead and simulate this. And you'll see that we have the top of the guitar body faced off. Go back to the program tab. The next thing we're going to do is program these pockets. So we're going to be using 2.5 axis pocketing. And the way we're going to approach this, we're going to machine. We have 2 pockets here that are deeper than this. So these 2 are the same depth. This one obviously is shallow. So we're going to go and program these 2 deep ones at the same time. So let's remove our default region. And because they're both at the same depth, we're just going to use the flat area region, and we're going to select both of these bottom areas. Not that. 2 of those bottom areas. So we got 2 areas we're going to be machining. And for the tool, we're going to use our 3/8 inch flat end mill. Let's go to the cut parameters. For pocketing, we're going to leave some stock because we're going to come in and finish the sidewalls with another profiling operation. And because it's roughing, 1/10 of a tolerance is probably enough. We're going to do an offset cut pattern. We're going to go around the pocket. And we're going to do start on the inside, step over 25 thousandths. All this is fine. And for the cut levels, where is the geometry in relation to your cutting? So it's at the bottom of the cut. And how deep are we going to cut? We're going to calculate that from the model. We're going to pick this button here. We're going to pick any point on the top of the cut and any point on the bottom of the cut. It doesn't have to be in the pocket. It could be over here, so long as it's at the top. And then we're going to pick a point at the bottom. So it comes up, it's 1.5 inches depth for the pocket. We're going to break this up into 1/4 inch cut levels, okay? And for the pocketing entry and exit, we'll just leave it set to a ramp entry, linear exit. Advanced cut parameters, we'll go ahead and leave all that set. Let's just generate that. Okay, so we have 2 pockets. Let's turn this on so we can actually see the pockets through the part. If you just rotate it up, you'll see that the pockets stop here. Okay. Now, what we're going to do is we're just going to copy this or clone it. And we're going to edit that. We're going to remove those. And with this time, we're going to use this curve as the bottom of the pocket because I've got an opening here. We're going to use the select curve edge regions. Pick that curve. Now, obviously, this is not as deep as the other pocket, so we're going to make some adjustments. We're going to use the same tool. All this is the same. Cut parameters, all of this is the same. So this is this is a good reason to use the clone operation command if you're going to use the same type of operation and if everything's going to be the same except for the cut levels in this case. So we're going to calculate a new depth. It's going to go from the top to the bottom, and we'll see that it is 3/4 of an inch deep. We're going to leave it in 1/4 inch cut levels. Everything else is the same. We should generate that. So there is our second pocket. And let's go ahead and simulate those. We'll just simulate until. So turn that off. So you see that we got it faced off. We got our one pocket and we got our second pocket. A real clean breakthrough there. Let's go ahead and finish those pockets. We're going to use a 2.5 axis profiling operation to go around the side walls. We're just going to do one cut level. We're going to do a profiling operation. And let's remove that. And we're just going to use the bottom flat areas and this curve as the bottom too. So we're going to pick our flat areas. So again, we're going to use that and that. Right click. Now to add two different types of regions, we're going to hold our shift key down and hit the select curve edge region button. We're going to select this curve. Oh, looks like I dropped that. Let's hit the shift key down and do that again.
You don't need to use the shift key, I don't think. Yeah,
I believe you do. And I don't know why it didn't work the first time. But anyway, we got the three different regions. And again, the profile is going to be at the bottom of all of these regions. So we don't need any avoid regions. For the tool, we're going to use the same 3/8 inch flat end mill. Everything here, we're going to use a tolerance of 1/1000, 0 stock, so it's going to follow the pocket walls. And we don't really need the cut direction. Well, we do. It's going to be set to mix, but it's only going to make one level around the perimeter. And all of this is fine. We can use the determine using 3D model. And for the cut levels, we selected the geometry at the bottom, and we're going to leave it set to 0, which means it's going to make one cut level at the bottom of each of these pockets. Okay, entry and exit. Since we're doing the side walls, and we don't want to have any trace marks at the bottom of the pockets, we're going to do a ramp entry, and we're going to do none for the exit, but we are going to overlap the exit by 1/2 inch to clean up any witness lines. For the advanced cut parameters, we will do some arc fitting. We'll set this to 0.2, which is 2 times the cut parameter tolerance or the global tolerance. And everything else, we should generate that. So here's our 3 profiling operations. Let's go ahead and simulate that. Slow this down a little bit. Okay, so now we have the pockets roughed and finished out, and we used 3 operations to do that. Now, we're going to look at programming these contoured face areas. As I mentioned, we have some new enhancements in 2024 that will make it a lot easier to program these fillets. So we're going to go in and we're going to do a 3-axis. And the first thing we're going to do is we're going to rough some of this material out around these fillets and around this contoured face over here. So we're going to use horizontal roughing. And we're going to remove that default region. And we're going to select two regions two nested regions in order to rough out in between those two regions. So we've got a perimeter curve here, and then we have an interior curve. So let's go ahead and select both of those. There's our outer perimeter, and here we're going to go in there and select our inner perimeter. So the roughing is going to occur between these two regions, and we won't worry about the start point or part surfaces in the roughing. We're going to use our smaller flat end mill since we got a tight fillet in here. And roughing tolerances is fine. We'll leave 25 thousandths of stock, offset cut pattern to go around it. And we use a mixed cut direction. All of this is pretty much okay. The cut levels, everything is okay. So we're not going to do anything special. We're just going to remove some material. We have no flat areas to clear or anything. We're going to use just a helix engagement, and it will put some arcs in there. So let's just generate that. So here is the roughing. It just took out some material over here and around the fillet perimeter. Okay, so let's go ahead and simulate that. If you guys have any questions, go ahead and put them in the questions bar. So we're going to do our roughing. Let's speed this up.
Hey, Don, there was a question on how to change start points on profiling. So when you get a chance, maybe you can show that.
Okay. We are going to do a profile on the bottom side to clear this out. Or we can go ahead and talk about the start points here if you want. We can do that now. So there's our roughing operation. So if we go back into the profiling, you can, in the cut perimeters tab, you have different methods for controlling where the cut start point is going to be. In this case, I just selected the midpoint of the longest side. So it's just going to calculate which side is the longest, and it's going to start there at the cut point. And then for control geometry, you also have a start points tab where you can actually define a point, and it'll start at that point. We don't really need a start point right now, so we're just going to leave this as it is. Okay, so we got the roughing. So let's go ahead and talk about the finishing around the perimeter. So we're going to use 3-axis, and we're going to use parallel finishing, a standard finishing operation in the standard configuration. And we're going to, for this application, since we're doing these fillets around in this contoured area, we're going to be using the part surfaces tab, and we're going to be using the contact extent condition. This is a new option in 2024, which is going to be making finishing these outer fillets a lot better. So the tool is going to actually complete this cut all the way down to the tangent line. So if you recall from our previous versions, the tool in parallel finishing would stop when the tool aligned itself with this boundary, so it wouldn't go all the way down. So in this case, we have this new option that takes care of that. So we're going to use this contact condition. We're going to go ahead and select these surfaces. We'll just start working our way around. Oh, sorry about that. Not sure why it didn't pick that. Okay, got to keep going then. Okay, just work our way around here. And we want to do this as well. Okay, so we got all of our surfaces selected. And for the tool, we're going to be using the 3/4 inch ball mill. And for cut parameters, 1/1000th tolerance. mixed cut direction. All these, we're just going to use the default parameters. We'll use a tighter step over. We're not going to use as tight a step over that you would normally use for a good surface finish. We're just going to do a step over that makes it relatively quick to generate. So let's just put, say, 10 thousandths. And for the Z containment, we need to not do anything there. We don't really need to do anything here. We will fit arcs. Okay, and let's generate that. This will take, it will take a little bit longer because we're calculating this contact condition around the boundaries. So normally the parallel finishing is relatively quick, but this time it's going to take a little bit longer to calculate that. And you might be able to hear the computer fan running to cool that processor up. Again, any questions, put them in the questions bar. So it looks like we got done here. So here is the parallel finishing. And what is really cool is that it covered the entire fillet all the way down to this contact point. So in the previous versions, the tool would stop when the toolpath would stop when the tool was aligned vertically with this boundary, which means it didn't go all the way down. So there's some other things you had to do to make it go all the way down. 2024, you don't need to worry about that. Just use the contact condition and the toolpath will stop when the full diameter of the cutter touches this boundary. That's cool. So let's go ahead and parallel finishing. It's always good method to use two of the parallel finishings, one cutting in one direction and one cutting 90 degrees from that. So we're just going to clone this. We're going to go back in and all we're going to do is change the cut angle to 90 degrees and we'll generate that. Any good questions? Again, just put them in the questions bar. Okay, so there's our parallel finishing in the 90-degree direction. Let's go ahead and simulate this. Let's turn that off. And so there's our last roughing operation. Let's go ahead and play that. So there's our parallel finishing, working its way around. Okay, so there's our parallel finishing in one direction, and we're just going to do this, play that, and we'll just pause this and go to the end. Okay, so now we have the top completely finished. Okay, so now comes the interesting part. So we need to program the bottom side. As I mentioned at the beginning, if you model your stock box, and this applies, it doesn't have to be to a guitar body, it applies to anything that you're going to be cutting. If you're going to be doing two sides of the part, again, you need to make sure that both sides are aligned, obviously, to make those cut line up. Okay, so in this case, as I mentioned, we actually modeled the stock box with the part inside the box. So one of the main differences between the standard and the professional is that in the standard configuration, you only have one setup. In other words, you can only cut from one direction at a time. in the standard configuration. And since we have 2 directions and we need to cut the bottom now, we're going to be saving this part out as the top and then saving it out again as the bottom. So we're going to have 2 models, 2 part files, one for the top, one for the bottom. Okay, so let's go ahead and save this out. Okay, and we'll just call this top. And then we're going to save. Now, I'm purposely doing the top first, and I'm going to do the bottom, and that's the part file that I'm going to work on next. So I'm doing the bottom second. Let's do save as. Bottom. Okay, so now we're working on the bottom version of this part. So now we need to actually rotate this geometry. And what's neat about the method right here is once you flip it over and align it to the world origin, everything is aligned automatically for you. You don't need to worry about anything else. It does it automatically. So what we're going to do though is we're going to use this option on the setup tab, orient part. You may not have used this. This is a relatively obscure option, and you probably don't use it a whole lot, but in this case, it's going to be critical. So we're going to use the orient part. And another thing I wanted to mention, you need to make sure that all of your geometry levels are turned on when you do this orient, because it's going to flip everything over. And if you don't want to leave anything behind, you don't want to leave one layer that's off and you got geometry over there, and then it gets everything kind of haywire. So make sure everything's turned on, and we're going to machine from the bottom. Okay. If you look at the large triad here, so this is the triad, this is the machining direction that we're going to be machining. So we're going to be machining on the bottom. So pick OK. So you see that it flipped everything over for you. Okay. But it didn't align it up with the world origin. We're going to go ahead and do that now. So with the stock box turned on, we're going to go ahead and redo the stock. We're going to pick copy model bounding box, pick OK. So now we have the stock aligned with our box, and we're just going to go use this align option called set world CS. What that does is this actually moves all of your geometry to the world origin in the CAD model, which, as you can see, it's over here. So we're going to go ahead and use align, set world CS. We're going to go by the stock box. Always go by the stock box as we have the stock modeled. And we're going to put the origin, the WCS, we're going to put it based on the lowest Z and southwest. So we're going to put it over here just like we had on the top. We'll pick OK. So it moves everything over to the world origin. Everything is contained exactly the way it was on the top. Actually, on your table, we flip the part over, okay? And you use the same 2 register pins on your table, and everything is aligned perfectly. So the stock, modeling the stock is the difference. If you try to do it without doing it another method, it makes it really complicated, and errors can be introduced, and it makes it real complicated sometimes to figure out where those errors are and how to fix them. So if you're using the stock model, the stock box method, everything is contained within that stock box, and everything gets moved with it. Okay, so we got it turned over. We got it positioned. And what's kind of neat, if you look at the work 0, it's automatically in the position that we had in the top side. So you don't have to mess with your work 0. Everything is all set up and oriented for you. So that's why using this method is one of the methods that makes it error-free. for you. Now we have all of these operations from the top side, and we're going to reuse many of those. So let's just look at what we're going to use. We go ahead and we don't need the stock box now. We're going to turn the stock off, turn the stock on. So there's our stock model. And so for the facing, we do want to use the facing. Let's go ahead and turn that stock box off for a moment. We're going to use the facing, and we're going to use the horizontal roughing and parallel finishing. So let's go into the facing, and everything's going to be the same except for the boundary. So we're going to remove that, and we're going to select this boundary curve here, and we'll generate that. So there's our new facing operation. Let's go into the pocketing. We don't need that. We're going to cut that out. Cut that. We don't need that profile. We're going to cut that. We do want to do the horizontal roughing, but we want to have some new boundaries. So we're going to go into here. We'll move those. And we're going to select these new boundaries here, that one and that one. And everything else is the same. We're going to just regenerate that. So
Hey
there's,
Don, there was a question on, since you have stock on the side of the part and you're machining the fillets, shouldn't you machine out the sides, because you are actually plunging into the sides if you're not cutting the entire box out?
you could do that by just offsetting this curve out and allowing some more cutout in this outside area.
Or you would just use the stock model and machine the entire stock model out, I would think.
Well,
right?
Yeah, but you may not want to waste all of that. You mean just cut it
That's
all
true.
out in a profile, or just machine all of it? You want to, you don't want to ruin all of your stock. You reuse parts of this expensive wood.
Yeah, sure. Yeah.
So, but typically what you would do, a lot of cases, you would just take this curve, this outer curve here, and just offset it out, maybe by the tool diameter or so. But the reason I had it tight in here, I didn't want the tool to plunge all the way down the side because I'm going to be profiling that out. But again, there's different ways of doing a lot of things. So if you want to get more material out, you can just offset this curve and use that offset curve as for one of the boundaries on the roughing. And yes, that would allow you to use the larger tool, because we used a smaller tool here to get in this little fillet area. So yeah, it's just a matter of how you want to do it, what you're comfortable with, how what your router can do as far as the accuracy, and just all kinds of things come into play when you make that decision. So we did the roughing, and as you realize as we're doing this, we're not redoing any of these operations. We're just reusing them, same parameters and everything, just giving them new boundaries. So our parallel finishing, we're going to go over here. We're going to remove all those, and we're going to work our way around to the new fillets. Okay, so we got all our fillets. Everything else is the same. Coming up next, we're going to show you some of the things you can do in the professional configuration. So let's go ahead and get this. Okay, so that's one side. I'm going to go ahead and cut that out, and I'm going to clone that, but I'm not going to regenerate it. You get the idea what it's going to do. Okay, so this is the bottom half. So we got the top half in the top file, the bottom half in the bottom file. Okay, one setup in each file. That's the limitation in the standard configuration. So this is how you would do it. in the standard configuration. Let's take a look at another model that I have here. Well, sorry. I guess it's this one. Oh, I got to move it over. Okay. So now, what would you do different in the professional configuration? Well, there's a lot of things that's going to save you some time, get better surface finish. It's going to be a lot easier to flip this over. So I'm not going to program it all, but I'm going to show you what the professional options are that we would use in this particular case. One of the first things is stock from selection. So we'll select our stock, and we're going to use the stock from selection, which means that in our stock, then we can see the actual holes. Let's go ahead and turn this off. Okay, so you see you see your actual alignment pin locations, so they're visible for you. Also, if you have any kind of exterior clamping, or if you've got you know, anything on top of this fastener, you can model those, and you can either add those as a stock, or you can go ahead and add those as a fixture geometry. But the stock from selection just allows you to get more information into your stock model. Okay, so we did the stock from selection. Facing, let's just go ahead and we're just going to just show you those. We're going to go through. These are all the operations we did in the standard. Okay, so now in the professional, we have another operation that you can use on this contoured surface that gives you this type of cut pattern. So it's called 3D offset pocketing. The step over is a constant step over regardless of the contour. So this distance between the cut pass is the same all the way down as it contours around, and it's in a circular cut pattern, an offset cut pattern, which this gives you a really good surface finish instead of just going one way and then back over the other way. You can do it all in one operation just by tightening up the step over. So in the 3D offset, this one is really cool. This is called 3D offset profiling. So what we did, we only selected one curve, okay? And as you can see, it's the same curve. It's just the same curve when we get to the top or the bottom. It doesn't matter where that curve is. It's just where it's aligned in the Z-axis of the part. And what this operation does, let's just take a look at it. So it allows you to set your cut pattern based on the curve. So we're going to do a zigzag cut pattern, and we're going to do cut both sides of the curve. So if you look at on this curve, so the curve is actually located here. So it's going to cut on both sides, one side and the other. The top side is going to wrap around this fillet, and the bottom's just going to, I'm not sure what the bottom's going to do. I guess it would wrap around down. We'll take a look at it again. So we're going to cut both sides, ½ inch. And again, you can adjust these to get the amount of wrap that you want. So let's just go over here and look at this again. Okay, so it is wrapping around a little bit further down than we really need. So you may want to, maybe 0.4 maybe would get better, but the 0.5 gets it all the way up to this fillet, and you can adjust that obviously. But what I'm getting at here is that this operation is a constant step over. This distance between the cut pass is the same here as it is here. So
it's a constant step over in 3D. So
yep.
what that gives you is maintains constant scallop height on the surfaces.
Yep.
Which will give you a really nice finish.
Mm-hmm. If you the only other way that you would do this in the standard maybe is either with parallel finishing, where you'd have only, you'd have to rotate your cut patterns, or
Oh,
in
you can't do it, Don.
yeah.
You can't do it. Yeah. No, you can't maintain
No,
constant
that's
scallop.
not, I
And
wasn't saying that it would.
yeah,
I was just saying the only other option you had is to use either the parallel finishing or the horizontal finishing. Horizontal
right.
finishing, as
Yeah.
you know, as it gets more to the horizontal, the step between the distance between the paths become larger because it's just slices in the Z axis. So this really a good pattern here to use for this fillet, as you can see. Again, another thing that's can help you out in the pocketing. You don't even have to do the pocketing. You don't have to use the pocketing. Just use the horizontal roughing, and it'll calculate that amount of stock. It'll calculate your depth for you, and then also we use the re-roughing, which automatically calculates the leftover material. You don't have to do a profiling, and figure out where the profile is going to go. Just use the roughing, use the re-roughing, and it'll figure all that out for you in the professional configuration. And then also another one that I like is the curve machining. What we did here is we used these two curves that we already have around this perimeter and that perimeter. So basically what it does is it places a toolpath, projects the toolpath down onto the part model uh, along this curve. You can go along the curve or you can go across the curve. We're just going along the curve, and we're using a zigzag cut pattern. We're starting on the right. It's going to cut both sides. So it's cutting a 1/16 of an inch on both sides. Okay, and here's the step over, and obviously your entry exit. What this does is it allows you to have a constant, well, I don't think this one is a constant, I think it's just a projection, but it allows you to have a cleanup area, a bandwidth along any curve. So if you have some maybe scalloping or some witness lines or something around where these fillets meet the top, or when this fillet meets this fillet, or when this fillet meets the top, you can clean those up using this cut pattern. Really good option to use. As you can see in the professional, you have a lot more options in the 3-axis, more advanced options for machining. And most of these relate to a better part finish, a higher degree of accuracy, when you're done cutting, possibly less rework, less hand sanding, or maybe just go over it with an emery cloth just to clean that up a little bit around it. But these toolpath methods will pretty much get it almost all the way done for you. And let's see what else, when we didn't look at the horizontal re-roughing. Basically, it's the same as the roughing. You're just telling it what the parameters are going to be for calculating what it does is you have to simulate the first roughing operation, because the re-roughing is based on the simulation model, the in-process stock model. So it only calculates that in-process stock model for this toolpath. So it's not going to re-machine everything, just with areas that you need to clear out. So that's in the professional configuration also. And then what's really cool is that in the professional configuration, you have multiple setups. You don't have to save this out to a separate file. You do the top, okay? This is the top. When you get that done, you just do another setup. You just rotate this over, okay? And just add another setup and another work 0. So you're automatically aligned for the bottom, and then add the operation. You just copy these, clone or copy these, just drag them down here and reassign the control geometry. Now on this side, I don't want to under stress or overstress this enough, is that having multiple setups, if you have a complicated part, even if it's not a two-sided part, people use multiple setups just for machining different areas. Okay, so you can use that as an organizational method, in your machining job, or you can actually reorient each setup in a different direction. So it's basically a 3+2. You're doing one orientation, you're doing another orientation, one for the top and one for the bottom.
And you're not messing with any of the CAD
Yep.
transformation. It's just the same model. All
Yep.
you're doing is you're approaching the part from different orientations. So,
Yep. You don't have to.
so Don, can you? There's a question on estimated time. Can you show the estimated time for each setup?
Yes, we can do that. Again, we didn't
machining
adjust any
feeds and speeds.
yeah, we didn't adjust any. So the values aren't going to be accurate, but we can show you how to do that. Just right click on that. If you pick information, it'll give you an estimated machining time for each of the operations for a total 1 hour and 42 minutes. These are just the default cut feeds and feeds values. So once you enter your own, obviously you're going to get a more accurate estimation of the machining time. So that's how you get the machining time for each setup. Uh, 49 minutes for the bottom side in this case. Was there any other questions? I think we covered just about everything. If we missed something that you wanted to know, again, just drop us an email and we'll get that answered for you.
Hey, Don, did you show the pro operations for the bottom part?
Oh, okay.
Did you see that?
So we got the 3D offset profiling, which is the same operation in the top. We just copied it down, and actually we didn't, you don't even have to change the geometry. We just same geometry. It calculates it in this orientation for the bottom, and really nice cut pattern. And also the curve machining as well, just to clean up the detail areas. Now I really like, in the, parallel finishing, I really like the fact, and this is in the standard configuration, I really like the fact that it calculates the boundary where to stop. That's a big, if you're doing any kind of mold machining, cavity machining, you're really going to say, oh, right, I'm glad we got this. So it's really going to help out a lot. But you don't need to do that in the Pro if you don't want to. You can go ahead and use the 3D offset profiling. Now, one thing about the 3D offset profiling, it's not calculating arcs. And I think there's no option to calculate arcs in it. So that way is one downside, but the cut pattern more than makes up for that.
I mean, the main reason is the 3D offset is on sculpted surfaces and it's on arbitrary planes. Yeah. So that's probably, and you can probably do it in the toolpath editor too. There's an arc fitting command, especially if you have the Pro configuration. You can go and do the toolpath editor and go to global edits and do an arc fit. That's one way of doing that. If you need that.
Okay, I'm not going to do that. It might take some time. We're at the end, but yeah,
no, it's pretty quick. It's actually pretty quick. You can run, yeah.
Okay. Fit arcs to toolpath. Okay.
You might want to, loosen that tolerance a bit. Yeah.
And let's pick OK. Oh.
Yeah. See the planes again. Yeah. You don't have that many planes here. There's only three principal planes.
Let's just talk about this for a second. So what we're talking about is, let's look at just the elevation view. You don't, in the bottom, it's not really that bad, but if you look at the top, you've got the path just wandering all over the place. In order to fit arcs, they have to lie on the XY plane, okay? So none of this here. So none of that really lies on the XY plane. Let's go up here. So in this case, we do fit arcs because it's going, in the X direction or the XZ plane. So you can fit arcs on any of the three principal planes. So we can fit arcs there. And let's look at the 3D offset profiling. Yeah, there we go. So you see that if the cut path is not lying on any of the principal planes. So it's dipping down around here, and it's, even though it looks straight over here, but it's being calculated based on the NURB surface. So it's not exactly on the plane. So it's not going to add them to that. But, the cut pattern and the benefits you get from this is really offsets the fact that you may not get as many arc motions as you might want, but you're going to get a great surface finish in there. So I'm not sure if the arcs would really get you a whole lot more in this case, because in the parallel finishing, this really comes in handy because you're only constrained to go in one direction. So fitting the arcs in there is very, very valuable to get a good surface finish when you can only cut, in one direction, and then the other direction, obviously. Okay. Any other questions, Joe? It looks like we're right at the end.
Yeah, I think we're good.
Okay.
No
Oh,
other
one other thing I want to
questions?
mention, sorry, Joe. One thing I want to mention, if you want the part files for this model and this setup and everything, just drop us an email and we'll send you the files. You can practice with it on your own. Okay.
Thank you all, and we'll see you next month.
Okay. Take care. Have a good day, everyone.
All right.
Bye.
Bye-bye.